Hello people, I'm Bharat Acharya. Welcome to a new video. In today's video, we're going to learn 8051 addressing modes. Addressing modes means the manner in which an operand is given in an instruction. I repeat, manner in which an operand is given in an instruction. Now, why do you need to know this topic? As you learn addressing modes, you understand how instructions look like. Later on, the next step after this is to learn the instructions and then get into programming. So, all of that depends upon your understanding of addressing modes. So, it's a pretty important topic as such, and from exam point of view, always important. Very big chance you'll be getting this in the exam, either as a 5-mark question or a 10-mark question, that's your luck, but very big chance you'll be getting it. So, coming back, what is addressing modes? See, when we write an instruction, there is an operand. What is an operand? The value on which you want to operate. Suppose you want to add a number 25. So 25 is your operand. Now how do you give this operand to the processor? How do you tell the processor that you want to add 25 is what is called addressing modes. One way, you just write add 25 as in you give the operand in the instruction. That's the easiest addressing mode called immediate addressing mode. Okay? Then you may not put the operand in the instruction. You may give the operand using some register. You may put 25 inside some register and say add the contents of this register. Again, you are still adding the value 25. But the way in which you are giving the operand is now different. Instead of giving in the instruction, you are giving it using a register. You may also store 25 somewhere in the memory and tell the processor add the contents of so-and-so location. So, instead of giving the operand, you are giving its address. So, etc. etc. So, these are the ways in which you can give an operand. That's what is called addressing modes. So, for the last time, the manner in which an operand is given in an instruction. How you give your operand, how do you tell the processor that this is my operand is what is called addressing modes. Okay, let's start. The first addressing mode called immediate. There are 5 addressing modes. Immediate, register, direct, indirect, index. This is immediate, this is register, this is direct. Indirect is huge, so then I'm going to take another side of the board to explain that. And the last one is index, which is again pretty small. Okay, let's start. The first one, immediate addressing mode. Data is given in the instruction. I say again, the data means the operand that you want to operate on. You give the data in the instruction. Example, move A, hash 25. You are saying move into A register the value 25. Right now don't look at the hash. You will understand what the hash does in 1 minute. Just give me 1 minute, you will understand what the hash. So right now ignore the hash. You're saying move into A register the value 25. So A register gets the value 25. So what happened? You gave your operand in the instruction itself. So then when the processor will fetch the instruction, you know the process. First of all, an instruction is fetched, then decoded, then executed. The moment a processor will fetch the instruction, since you have given the operand in the instruction itself, as the processor fetches the instruction, it gets the operand. So will it have to search for the operand? No. So will it waste any time? No. That means the operation will be performed immediately. Hence the name immediate addressing. The operand is an immediate operand. It is immediately provided in the instruction. But first tell me, did you understand what's the meaning of immediate addressing? Now, why is the hash there? When you write move A, 25, it can have 2 meanings. 25 can be the data. 25 can also be an address where the operand is stored. Any number can be a data also, can be an address also. So how do you tell the processor whether this number is a data or this number is an address? The trick used in 8051, every processor has a trick for doing this. In 8085 it is MBI that we write. In 8086 we put a square bracket. So in 8051 the trick used is, you put a hash. Any number with a hash is data. Any number without a hash is address. Did you understand this? Applies across the board throughout 8051. After this point, in 8051, if you see an instruction in which there is a number, don't jump to a conclusion. Look for a hash. If there is a hash, then that number is data. If there is no hash, that number is just an address. The data will come from that address. Is that clear? Now, so the first example, move A, hash 25, A gets the value 25. Did you understand? Move DPTR. So when you get this question in the exam, You're going to write all the addressing modes. You're going to write the explanation, nice full the definition, the explanation, blah blah blah. Whatever you write will not carry any weightage unless you have supported it with examples. The crux of this answer are the examples. I've seen students, because today you can get a photocopy of your answer sheet where you can see your marks. So students say, I didn't get good marks. I asked them to get a copy of your answer sheet. You see the answer sheet, you've written 2 pages of the answer, but you've not written examples, or maybe the examples are wrong. Either way, it means the same. You'll get no marks. You'll end up getting 2 out of 10, or maybe 3 out of 10. So if you want marks in this answer, you need to write examples. Minimum 1, ideally 2. If I was you, I would write 2 examples of every addressing mode. Now, those 2 examples have to be different from each other. It can't be the same. Move A, 25, move A, 35 is the same example. So it has to be something different. So here, we are taking the example of an 8-bit register and another example of a 16-bit register. If you note 8051, DPTR is the only 16-bit register that's available to the programmer. There's another one, PC, but you can't directly initialize PC. PC is auto-incremented after every instruction anyway. So, move DPTR, hash 2000. 2000 is a 16-bit number, goes into a 16-bit register. So DPTR gets the value 2000. Again, if you know DPTR properly, it is a combination of 2 registers, DPH and DPL. So DPH gets the higher byte, that is 20, and DPL gets the lower byte, that is 00. So DPTR gets the value 2000. The important thing is, in both these instructions, the data was there in the instruction. Since the data is there in the instruction, it is classified as immediate addressing mode. The trick to remember is you have to put a hash in the instruction. Tell me, did you understand this? So that was immediate addressing mode. Now, to the next one, register addressing. Register addressing means instead of giving the data in the instruction, we will give that same data but using a register. Example, move A, R0. Look at that. When you write move A, hash 25, you're saying A should get the value 25. Move A, R0 means A will get the contents of the register R0. Means instead of giving the data in the instruction, you are saying the data will come from a register. Hence the name register addressing mode. Did you understand this? Now move A, R0. If R0 contains 25, A will get the value 25. Will the value 25 be removed from R0? No. There is no cut in this subject. There is only a copy. I'm sure you know the difference between a cut and a copy. So there's only a copy. The value will remain in R0 but will also be copied into A register. Did you understand? Now, another example. Move R1, A. Who gets what? R1 gets the value of A. So whatever is the value in A register will be stored into R1. Please tell me, did you understand this? Now, one more example. Move R1, R0. R1 gets the value of R0. Nah, this is not allowed. So what is not allowed? Writing 2 RAM registers in one instruction is not allowed. Now, please watch the videos in the same sequence that they are there in the channel, in my channel on my website, because each video has something to do with the previous one. You're learning, now you've gone too deep in the chip, so you need to know some background about the chip. So 8051 in the internal RAM has 32 registers which are divided into 4 banks. Each bank has 8 registers, R0 to R7. Now, they are called RAM registers. You cannot write to, or general purpose registers if you want to say, you cannot write 2 RAM registers in the same instruction. Applies to the whole instruction set. There are 111 instructions in 8051. In not even one of those instructions, you are not allowed to write 2 RAM registers. Are you clear? So move R1, R0, R0, R1, R0, R2, R2, R3, R3, R4, R4, R5, R5, R6, etc. is not allowed. I just gave the reason why it's not allowed. I never say things without a reason. If I'm saying this, you should understand. I just gave you a hint why it's not allowed. See, the whole university knows that this is not allowed. Every student knows it. It's written in every textbook. Very few students know why it is not allowed. Why is this not allowed? If you allow writing 2 RAM registers, that will create 64 different combinations. Tell me, did you understand this? You know permutations and combinations. There are 8 registers, R0 to R7. Keep altering them, you will get 64 such combinations. So what happens if you get 64 combinations? As the registers change, the opcodes change. So that means there will be 64 opcodes. There will be an opcode for move R0, R1, move R0, R2, move R0, R3. Like this, there will be 64 opcodes only for move, another 64 for add, another 64 for subtract. Come on, are we crazy? You cannot have so many opcodes for one instruction. It is just not possible. So, to reduce the number of opcodes, writing two RAM registers RX, RY in the same instruction is not allowed. Did you understand this? So then you would be asking, what if I want to put the value of R0 into R1? How do I do it? Come on, you're smarter than that. How do you do it? You transfer the value from R0 into A, and then from A into R1. That's exactly what we have done in these two instructions. Exactly. Transfer from R0 to A, then from A to R1. So when you can do it so easily using two instructions, why waste 64 opcodes for doing the same thing? That's why writing two RAM registers is not allowed. More importantly, the thing that I want you to understand is, in these instructions, the data is given by a register, whereas over here, the data was given in the instruction. So that was immediate addressing, this is register addressing. Are these two addressing modes clear? Now, the topic will go a little higher. Come on. The next one, direct addressing. Address is given in the instruction. Instead of giving the data, we are giving the address. Why aren't we giving the data? Because we don't have the data. If we had the data, why would we not give? Many a times you have the data. Many a times you have the address. Let me ask you a question. Write a program to add the numbers 25 and 35. Now you know the data. The data values are 25 and 35. You will put 25 in A register, then add 35 to A register. Move A, hash 25, add A, hash 35. That's it. Your job is done. So in this case, you knew the data. So you use immediate addressing. I change the question. Write a program to add the contents of location 25 and 35. That's it. Now you don't know the data, but you know the address. So there should be some addressing mode that helps you get the data from an address. That's when you use direct addressing mode. Please tell me, did you understand this? So, direct addressing mode, address is given by the instruction, not the data. You give the address, processor will go to that address and from there will get the data. Did you understand this? Now, there is a catch over here. The address that you write can only be an 8-bit address. To restrict the size of the instruction, the address has to be only an 8-bit address. Did you hear what I said? 8-bit address means 1 byte address. Now, there are 4 memories in 8051. Again, see, there is a connection to the previous lectures. Please watch the videos in the sequence. You will still understand. Even if you don't, I will still keep giving the linking points. But if you want to really understand it the best way, it's like reading a book. You got to read it chapter by chapter. You can't just pick up some random thing and start reading. You will understand most of it, but there will be issues in the middle. So, coming back, there are 4 memories in 8051. Internal RAM, internal ROM, external RAM, external ROM. The only memory of 8051 which uses an 8-bit address is internal RAM. Every other memory has a 16-bit address. Are we clear? So, direct addressing mode applies only to those addresses which are 8-bit. Since only internal RAM uses 8-bit address, it works only for internal RAM. And for SFRs, if you saw the video on SFRs are special function registers. To reduce the number of opcodes, we have allotted them also addresses. What addresses? The ones which are left over from the internal RAM. Internal RAM uses only addresses from 00 to 7F, giving a whole range of addresses 80 to FF, totally free. Those are allotted to the SFRs. They are also 8-bit addresses. Altogether they are 00 to FF. So, direct addressing mode works for internal RAM and SFRs. Don't confuse yourself. It's easier than what you're thinking. If you're thinking this is complicated, no. This is not complicated. It's pretty easy. Right now, ignore SFRs. What it mainly works for is internal RAM. Then I'll show you an example of SFR also. Don't worry. Now, example. Move A, 25H. Come on. Is there a difference between move A, hash 25 and move A, 25? Yes. That is hash 25. That means it is data. This is just 25. It is not data. It's an address. So you're saying move into A register the contents of location 25. In the explanation, this is how you write it. If you want to write it in text, of course you can write A register gets the contents from location 25. But if you don't want to bore the examiner with so much verbose answer, just write move A gets the data from location 25. That square bracket indicates location or contents of. So A gets the contents of location 25. So this is the internal RAM. In that, internal RAM goes from 00 to 7F. In that, there is a location 25. The data from that location will come inside A register. Did you understand this? Now, move 30H, A, the reverse operation. Store the value from A register to location 30. Both these instructions, we have given the address in the instruction, so they are a part of direct addressing mode. So you're storing the value from A register to location 30. So if you do these two instructions back to back, first you took the data from location 25 into A, then from A, you're storing that same data to location 30. So side by side, we have seen a small program also. These petty programs asked in Viva oral exam. Write a program to transfer the contents from one location to another location. First take the data from that location into A, then from A store it into the other location. Tell me, did you understand this? Now, let me ask you a small exercise, okay, just to see whether you understood all this. This is location 20, this is 30, this is 40. Excuse me. Take the data from location 20 into A, transfer it into a register R0, take the data from 30 into A, add the value of A and R0, answer will come in A, add the number 55, answer will still come in A, store the result at location 40. Come on, give me the instructions for doing this. I repeat the question. Take the data from 20 into A, store it at R0. Take the data from 30 into A, add these two, answer will come in A, add the number 55, answer will come in A, store the result at location 40. If I was you, I would pause the video right now. Write the answer that comes to my mind. It's okay. Write it. Then verify it with what I'm going to write on the board. If you get it right, pat yourself at the back. Be happy. That's it. That means you understood whatever we've done so far. Come on. Take the data from location 20. Move A, what? Hash 20 or 20? 20. Good. If you write hash 20, A gets 20. I don't want 20. I want the contents of location 20. Transfer it to R0. Move R0, A. Now take the data from 30 into A. Move A, 30. Now add A and R0. Add A, R0. Answer has come in A. To that, add the number 55. The number 55. Add A, hash 55H. The hash because it's the number, it's the data. The answer comes in A. Store the result at 40. Move 40H, A. I hope you understood this. Now, so what we've done is I was just playing with you just to get you accustomed to all the addressing modes that we have learned. We just used up all the addressing modes that we just learned. Now, to show you some more interesting examples. Move, in the exam you don't have to write so many, you have to write 2. But since I'm teaching you, I'm showing you all these examples. Move 30H, hash 30H. Perfectly valid instruction. You're saying move into location 30, the value 30. This is location 30, this is value 30. Location 30 will get the value 30. Please tell me, did you understand this? Move, keep looking. Move 01H, 00H. Many people think this is a wrong instruction. This is a perfectly valid instruction. The reason why people think this is a wrong instruction is because this is not allowed in microprocessors. In microprocessors, you can transfer between register and memory location and a register and another register. But you cannot transfer between two memory locations. But in microcontrollers, it is very much allowed. Why is it allowed? Because the memory is internal RAM. That means it's inside the processor. So it works like register to register. That's why it's allowed. So move 01H, 00H. Who gets what? Location 01 gets the value from location 00. Tell me, did you understand? Now, if you're a real deep thinker, if you started liking the subject and you're finding the subject interesting, and you start thinking over it more and more, you realize location 01 and 00 are nothing else but R1 and R0 of bank 0. Tell me, do you understand this? In the internal RAM, location 0 is basically R0. Location 1 is basically R1. All of that of bank 0. You cannot write move R1, R0. But you can write move 01, 00. It does the same thing, but this is allowed, this is not allowed. And I gave you the reason. I never say anything without a reason, because I'm supposed to teach you. I'm not supposed to just tell you. There's a big difference. If you write move R1, R0, this creates 64 opcodes, because for a register, for every register, there is a different opcode. Registers are part of an opcode, but these are numbers. Numbers are never a part of an opcode. they are written separately as operands. So because these are numbers, writing these two numbers in one instruction is allowed. So if you ever want to transfer the value from one register to another register, there are two ways to do it. Either do it via a register in two instructions, or directly do it using their addresses. So it is effectively transferring the value of R0 into R1. Did you understand? It's a very interesting example, that's why I just took it. As I said, you don't have to take so many in the exam. Another interesting example. Move A, 80H. So who gets what? A gets the value of location 80. But please understand, there is no location 80. Internal RAM ends at 7F. That's it. 80 to FF are unused addresses which are allotted to SFRs. So 80 is the SFR address of port 0. So when you write move A, 80, what it actually does is A gets the value of port 0. So that's what I said. Direct addressing mode is applicable for internal RAM and SFRs. These are all examples of internal RAM. This is an example of SFR. Please tell me, did you understand this? With this, we are done with direct addressing mode. Okay. So now, we come to the most important, the most useful, the best addressing mode. Which one? Indirect. It's my favorite also. More than 97% activities in a computer are done using indirect addressing mode. Now, why so much? Look here. First, let's see the definition. Data in the instruction, data given by a register, address given in the instruction, address given by a register. So, again, we are going to give an address. Here also we gave an address. Now, again, we are giving an address. Here, the address was given in the instruction. Now, we are going to give the address using a register. Now, direct addressing mode was only for internal RAM. Yeah, and SFRs, but talking in terms of memories, it was only for internal RAM. Indirect addressing mode is for both internal RAM as well as external RAM. Again, only RAMs, nothing for ROMs. Internal RAM and external RAM. Why are they all so focused on RAMs? Because RAM contains data. ROM contains programs. What do you want to add, subtract, multiply data? Do you want to add two programs and make a big program? No. You want to add data, you want to subtract data, you want to multiply data. So all these instructions basically are focused on the RAM because RAM contains data. Okay, so coming back, direct addressing mode was only for internal RAM. Indirect addressing mode is for both internal RAM and external RAM. We start and just move the mic on the side. So, we're discussing indirect addressing mode. Now in indirect addressing mode, address is given by a register. Since it works for both internal RAM and external RAM, the concept is the same, only the register will change. Why? Internal RAM uses 8-bit addresses. External RAM uses 16-bit addresses. So, to access internal RAM, you need an 8-bit register. To access external RAM, you need a 16-bit register to give the address. The only 16-bit register that you can directly use is DPTR. So for external RAM, you'll be using DPTR, and for internal RAM, you'll be using R0 and R1. Now, before you go to internal RAM, okay. First of all, for external RAM, you're using DPTR because it's a 16-bit register. I hope you understood that. Now, for internal RAM, you can use anything from R0 to R7 because they are all 8-bit registers. Yes, but they have restricted it only to R0 and R1. Why? Again, the same thing. If they use all the registers, that means you'll have to create 8 opcodes for every instruction because you'll be allowing all the registers. As the registers change, the opcode changes. Now, instead of wasting 8 opcodes on it, they've restricted it only to R0 and R1. Now, don't misunderstand. I'll tell you what does this mean. Here, the register is giving data. Here, the register is giving an address. If you want to give data, you can use any register from R0 to R7. But if you want to give an address, you can use only R0 or R1. Tell me, did you understand this much? Now, let's see the instruction. Move A, at the rate R0. At the rate R0. Who gets what? A gets the contents of the location pointed by R0. Look here. This is your internal RAM. In the internal RAM, this is location 30. I want the data of location 30 to come into a register. Now there are two ways to do it. Either by direct addressing or by indirect addressing. If I do it by direct addressing, I will write move A, 30H. Who gets what? A gets the contents of location 30. That is direct addressing. That's like catching your nose like this. But if you want to do it using indirect addressing, you first initialize R0 with the value 30. How? By writing move R0 comma hash 30H. Yes, hash 30. For R0, 30 is data. I have initialized R0 register with the number 30. Now, using that as a pointer, I will get the data from the location pointed by R0 by writing move A comma at the rate R0. Who gets what? A gets the data from the location pointed by R0. Means the location whose address is given by R0. Since R0 is 30, A gets the data from location 30. Tell me, did you understand this? No? No problem. I'll repeat it. There's no problem. Look here. Move A comma R0. Who gets what? A gets the value of R0. If R0 is 30, A will get 30. Did you understand this? Now, move A comma at the rate R0. Who gets what? A gets the contents of the memory location pointed by R0. Since R0 is initialized with the value 30, A will not get 30. A will get the contents of memory location pointed by R0. I'm just using R0 as a pointer. Using that pointer, I'm getting the data from the location pointed by R0. Tell me, did you understand this much? Now, you would be wondering, if I want data from location 30, I could have simply written move A comma 30. Why did I go around doing this whole thing? If you write move A comma 30, yes, that is simpler. Even I agree. But simpler is not better. You want to do complex things, this is not going to help you. If I tell you, get me the data from location 30, that's it. That's my question. Get me the data from location 30. Which addressing mode are you going to use? Direct. Even I will use direct. A simply will get the data from location 30. But I change my question. I tell you, get me the data from 10 locations. Starting from location 30, one by one, I want data from 10 locations. Did you understand my question? Now, if you write move A comma 30, that is direct addressing mode, you will then have to write move A comma 31, move A comma 32, move A comma 33. Like this, you will have to write 10 times. Is that good programming? That is rubbish. You don't do programming like this. You want to do something 30 times or you want to do something 10 times, you don't write it 10 times. You write it once and you put it in a loop. That's called programming. Now, will you achieve anything by looping this instruction? No. It will always give you data from location 30 no matter how many times you execute it, because you have written the address in the instruction. But if you write move R0 comma hash 30, as in you have initialized R0 with 30 and now saying A gets the data from the location pointed by R0, you can put this in a loop and in the loop go on incrementing R0. As you increment R0, first time A will get data from 30, increment R0, next iteration A will get data from 31, 32, 33, 34. As many iterations as you perform, you'll go on getting data from different locations. That is the advantage of indirect addressing mode. The address is given by a register. That register can be incremented or decremented inside a loop to access a series of locations. You want to access one location or two locations, you use direct addressing because it is simple. But who accesses one location? What is stored in one location? 1 byte. There is nothing of 1 byte in the modern world. Everything today is kilobytes, megabytes and gigabytes. Now if you want to access so many bytes, you cannot go on writing that instruction all the time. Then you use indirect addressing mode and use it as a pointer. I'll give you more examples. You ought to understand. This is not rocket science. Come on, this is so simple. It is a basic thing. Suppose in C programming, okay, there is an array by the name ARR. It has 10 elements. Element number 0 to element number 9. Every element has some value. If I write x is equal to ARR 5, I get the value of element number 5. If I write ARR 6, I get the value of element number 6. If I write ARR I and I initialize I as 5, I will still get the value of element number 5. This is called indirect addressing. What is the advantage of doing this? You can put this in a loop and go on incrementing I. That is something you can never do once you have written 5 inside the instruction. So when you give the address in the instruction, it is called direct addressing. If you give the address using a register, it's called indirect addressing. The advantage is the register can be incremented in a loop to access a series of locations. I hope you understood my point. I'm stressing so much because 9 out of 10 programs you'll write will be done using indirect addressing. If you don't know indirect addressing, all you'll end up doing in your life is add 2 numbers. You want to do serious programming, everything is done using indirect addressing mode. I hope you understood what this does. Now, so for the last time, for my happiness, move A comma at the rate R0. Who gets what? A gets the contents from a location pointed by R0. What is the difference between at the rate R0 and R0? Simply R0 will give you data. At the rate R0 will give you the contents of the location pointed by this register. Are you clear? If R0 is 20 and you write just R0, you get 20. If you write at the rate R0, you get the contents of location 20. I think you understood what I said. Now, if you understood this, then answer this one for my sake. Answer by yourself. Move at the rate R1, comma A. Now answer. What happens? Is A getting the data or giving the data? Exactly. A is now giving the data into R1? No. Into a memory location pointed by R1. Did you understand? If R1 is 20, A is getting stored at location 20. You could have done the same by writing move 20h, A. But that instruction cannot go in a loop. This can go in a loop, and by going on incrementing R1, you'll go on storing data at different locations. So let me ask you one more question now. Come on, look here and answer. This is location 20, this is location 30. Take the data from 20 into A, store it at location 30. Come on, move A, 20h, move 30h, A. Now this was done using direct addressing mode. Why? Because you want to transfer one number from here to here. Now you think this will be an exam question? Never. Write a program to transfer a block of data from location 20 to location 30. Can this be an exam question? All the time. Such a popular question. This is called block transfer program. This is what happens when you do a copy paste. Come on. So you want to access a series of locations. Which addressing mode will you use? Direct or indirect? Absolutely, indirect addressing mode. So you need 2 pointers now. 1 pointer for the source, 1 pointer for the destination. You'll initialize R0 with the value 20. You'll initialize R1 with the value 30. Take the data pointed by R0 into A, store it at the location pointed by R1, increment R0, increment R1, put it in the loop. Come on. Initialize R0. Move R0, hash 20. Move R1, hash 30. Now take the data pointed by R0 into A. Move A, at the rate R0. Store it at the location pointed by R1. Move at the rate R1, A. Increment R0. Increment R1. Put this in a loop. The only thing you don't know so far is how to make a loop, which again you'll learn very soon. Once you know how to make a loop, you know how to write this program. That's it. This is called a block transfer program. Now, all throughout we had to use indirect addressing mode. So that's what I'm making you understand. All serious programming is done using indirect addressing. I think you understood indirect addressing. Now, once you understood the concept, these two will just fly by. Now, 5 minutes or 7 minutes to the end of this video. Maybe 10 at the most if I explain something interesting which is extra. Now, this was indirect addressing mode for internal RAM. This is indirect addressing mode but for external RAM. For external RAM, what's the difference? The concept is the same, just that the address now is a 16-bit address. So it won't be given by R0 or R1, it will be given by DPTR. So example, move X, A, at the rate DPTR. Who gets the data? A. From the location pointed by DPTR. Since the instruction is happening on external RAM, the instruction is called MoveX. Move works on internal RAM. MoveX works on external RAM. I repeat, move works on internal RAM, MoveX works on external RAM. Did you all understand this? Now, look here. So, who gets the data? A, from an external RAM location pointed by DPTR. In case you're wondering, DPTR is 16 bits and A is 8 bits, no, it doesn't matter. Yes, that's true. DPTR is 16 bits. What is DPTR giving? The address. The data from that address will be 8 bit. Every location carries 1 byte, and that data will come inside a register. Tell me, did you understand? Give me the reverse example. MOVEX @dptr, comma A. Now you are storing the value from A to the location pointed by dptr. Now since both these instructions work on external RAM, in the explanation you may write the words external RAM, or you may just put this symbol. This symbol is called caret. This is just a way of writing. If you don't know this, it doesn't matter. X indicates that it is external RAM in the instruction, and caret indicates that it's external RAM in the explanation. Both are indicating the same thing. Which is more important? X. That is syntax. This is just a way to write external RAM. You don't like it, you can write external RAM. Doesn't matter. But that is important. That is the syntax of the instruction. I hope you understood it. Now, Intel has allowed a new feature. You can also access external RAM using only an 8-bit address given by R0 or R1. Don't confuse yourself. R0, R1 give 8-bit address which is ideal for internal RAM, and DPTR gives 16-bit address which is ideal for external RAM. So this is how normally people work. Now there is an added feature given by Intel, facility. You can also use R0, R1 to access external RAM. How does this work? Look here. This is external RAM. External RAM has addresses 0000 to FFFF, which means they are 16-bit addresses which are given by DPTR, which can access the whole external RAM, giving you 2 raised to 16, which is equal to 64K, 65,536 locations. My point is, using DPTR, you can access the whole external RAM 0000 to FFFF. But as an added feature, if you want to access location 50 of external RAM, now 50 is basically 0050. Now you don't need to give the full address. Even if you give the lower byte, the processor assumes the higher byte to be 0. So this trick can work up to 00FF. That means you can access these locations even using just an 8-bit address, assuming the higher byte to be 0. 8-bit address is given by R1 or R0. So you can use even R1, R0 for external RAM. Nobody does it. Trust me, nobody does it. Why? Because the range is so small. It gives you a range of 2 raised to 8, that is 256. If you want to access external RAM, what would you prefer to use? R1, R0 or DPTR? Obviously DPTR. It gives you full range, 65,000 locations. This gives you a very small range. Don't think this is half. No. This is not half. This is 256. That is 65,000. This is 1 upon 256 into 256 is 65,000. 2 raised to 8 into 2 raised to 8 is 2 raised to 16. So this is 1 upon 256. That is 0.04%. It is so small as compared to the full range that you could have got. So nobody really uses it, but in theory it exists. And you know how some examiners are, right? Unless you write the whole answer, though something may not really be useful in the world, but since it's a part of the answer, you want full marks, you've got to write it. So just for the sake of that, know this. You don't really use it in programming, but it is something that is there. You can't be selective while studying. You should know everything. There is for loop, there is while loop, there is do while loop. Everybody uses for, but you should know the other loops also. Then whichever one you want to use, you use. So it's a facility nobody really uses, but still you got to know. You can access external RAM even using R0, R1. Give me the instruction. Come on, quickly. MOVEX A, comma, @R0. Who gets the data? A. From the location pointed at R0 in the external RAM. Now in this instruction, if I remove X, it is still a valid instruction, but it will work on internal RAM. It will become this instruction. Do you understand this? And if I remove the X also and the @ also, it is still a valid instruction, then A will simply get the value of R0. That means it will become that instruction. So there is a difference between move A, R0, move A, @R0 and move X A, @R0. I hope you understood all of that. Now, the reverse instruction. MOVEX @R1, A. A will be stored at the location pointed by R1 in the external. Please tell me, did you understand this? Now those were all examples of indirect addressing mode. Now we come to the last and final one, the easiest one, index addressing mode. Just one second. So, index addressing mode. Tell me, direct addressing mode is only for internal RAM. Indirect addressing mode is for both internal RAM and external RAM. So far we are only focusing on RAM. Index addressing mode is only for ROM. Okay? Why is it like this? You'll come to know very soon. It's so interesting. Just hold on. First learn the addressing mode, then I'll tell you its use. It may seem very silly, but it's not. It's very useful. Now in index addressing mode, address is given as a sum of 2 registers. Address is not given by one register, it is given as a sum of 2 registers. So it is basically an extension of indirect addressing mode. In indirect addressing mode, address is given by one register. Here address is given by a sum of 2 registers. Which 2 registers? A plus DPTR or A plus PC. Let's see an example. Move C. Now, move C. Move is for internal RAM. Move X is for external RAM. Move C is for ROM. Okay, it's for ROM. So when you write move C, so by C, ROM is also called code memory. ROM is used to store programs. So for that code memory, the C comes. Anyways, so move C, A comma at the rate A plus DPTR. Who gets the data? A. Since you've written at the rate, that means it becomes an address. A gets the data from the address given by A plus DPTR. A gets the data from the location pointed by A plus DPTR. Another example, move C. Don't put a reverse example over here, okay? The reverse, no, it won't work because it's wrong. You cannot write into ROM. You can only read from ROM. So both examples will just read from the memory. So here A gets the data from the location pointed by A plus DPTR. Here A gets the data from the location pointed by A plus PC. Both are very obvious examples. Tell me, did you understand this? Now, what's the use? People think index addressing mode is useless. Oh, it is so interesting. When you know the use, you'll be amazed. Okay, just give me a minute. We just have to move the camera this way. So we are discussing index addressing mode. Index addressing mode of 8051. It is for ROM. Okay, only for ROM. Now, ROM is called program memory. RAM is called data memory. So that means you store data in RAM and you store programs in ROM. But ROM doesn't contain only programs. ROM also contains some data. What data? Static data. Data that we don't want to change. Hence you store it in ROM. Permanent data. Permanent data is always stored in the form of a lookup table. Okay, you'll know what it is. Okay, just tell me. So this index addressing mode that we are learning, where address is given as a sum of 2 registers, is an ideally created addressing mode suitable for accessing a lookup table. Now, what are lookup tables? Let's give you a small picture. Look at this. This is called a 7-segment display. Now, in a 7-segment display, there are 7 segments, which are generally LEDs, can be normal bulbs also. So these are 7 segments. A, B, C, D, E, F, G, and if there is a dot, some displays have a point, like some meters, like in a car or something, whatever. So if you have a point, a decimal point, that will be H. Otherwise, if it's not there, the H won't be there. Anyway, so if you want to display 1 on this display, you don't send 1. Sending 1 will not display 1. You send a pattern that will activate B and C and deactivate the others. That's how 1 appears on the screen. Tell me, do you understand this? So, that pattern is created by these bits. A, B, C, D, E, F, G. Whichever bit you keep as 1, that segment will be on. Which you keep as 0, that will be off. Now, it's not always like this. It can be the other way around also, depending upon active high and active low, called as common cathode and common anode. Anyways, not getting into that, keeping it simple, assuming active high. If you want to display 1, B and C should be 1, the other should be 0. Now look at this number. This is 0, this is 6. So the whole number is 06H. If you send 06H, you end up displaying 1. So 1 is called the 7-segment code. So 06H is called the 7-segment code of 1. Tell me, did you understand this? To display 1, you send 06H. Like this, there are 7-segment codes of all digits from 0 to 9. Okay? Now, are these codes ever going to change? No. If you want to display these numbers regularly, suppose it's a traffic signal or a railway station or anywhere you want to show a digital clock or anything of that sort, you want to keep displaying such numbers. To display any number, you need its code. These codes are never going to change. So you store these codes in the memory as a table. Such a table is called a lookup table, also called a reference table. So this lookup table contains 7-segment codes of all digits from 0 to 9. What is this? Is this program? No, this is data. Our knowledge so far says that data is stored in RAM. Will you store this in RAM? No, because you store it in RAM is volatile. The next time you reset your device, the contents of RAM are lost. The lookup table will be lost. You won't lose it. No, it means it will be stored in ROM. Now, since it's stored in ROM, you need an addressing mode to access this lookup table. Now, how they've created this addressing mode, see how brilliant it is. The code of 0 is stored at 0400. I've just taken some address. 0401 has the code of 1. 0402 will have the code of 2. 0409 will have the code of 9. I want the code of 5. Where is it? Yes, 0405. Say it again. 0405. Make it better. 0400 plus 5. Why did I say like this? Because the table may not start at a sweet number like 0400. It may start at a stupid number like 1359. If it starts at 1359, still the code of 5 will be at 1359 plus 5. If it starts at 1286, the code of 5 will be at 1286 plus 5. So where is the code of 5? Starting address plus 5. Where is the code of 7? Starting address plus 7. Where is the code of any number? Starting address plus that number. That means that address can be formed by adding 2 registers. This is DPTR, this is A. You will initialize DPTR with 0400 and the number whose code you want, you use it as an index in this array. That's what is called index addressing. To get the code of 5, you will initialize DPTR with 0400. That's the base address of the array. That means where your table begins from. You want the code of 5, put 5 in A, use it as an index in that array. Now write your magic instruction. What an instruction. So wow instruction used so much in programming. Move C A comma at the rate A plus DPTR. Works like magic. Who gets the data? A. From the location pointed by A plus DPTR. DPTR is 0400, A is 5. The total is 0405. From 0405, you're getting the code of 5, which you are again taking in which register? A. So, before this instruction, A was the number that you wanted to translate into its code. After the instruction, A contains the code. Before this instruction, A was 5. After this instruction is the code of 5. So what happened? Magic happened on A register. This is A register. You kept 5 in it, you did something and it became the code of 5. What is that magic? Move C A comma at the rate A plus DPTR. It magically translates the number into its own code. Let's see one more example. After displaying 5, let's say you want to display 7. To get the code of 7, will you initialize DPTR again? No, you never change DPTR. DPTR will be initialized only once in the whole program. Put the number 7 in A by writing move A comma has 07. Move C A comma at the rate A plus DPTR. Who gets the data? A. From the location pointed by A plus DPTR. DPTR is 0400 plus 7, that is 0407. You will get the code of 7. So A was 7, becomes the code of 7. You want to put the code of 9, put 9 in A, write move C A comma at the rate A plus DPTR. That 9 becomes the code of 9. Any number that you want to translate into its own code is done using the instruction move C A comma at the rate A plus DPTR. Please tell me, is the use of this instruction clear? People think what a ridiculous instruction. It's not. Why would it be? This is not nature. We don't create. We don't just woke up and saw all this was there around us. All of this is made by us. If it's made by us, everything has a simple reason behind it. Instead of just looking at it, ridiculing it, thinking why would they even create this or it's silly. It's not silly. Everything has a reason. So the reason why they created this addressing mode is the address will not be given by one register, it is given as a sum of 2 registers. One acts as the base of the array, the other acts as an index in the array. So it's an ideal addressing mode to access an array, also called a lookup table. Sometimes this question comes like this also in the exam. Explain how to access a lookup table. This is the example that we take to explain it. I hope you understood it. So let's just take a quick recap of all the addressing mode. First one, immediate addressing mode. Immediate addressing mode, data given in the instruction. Example, move A comma hash 25. So data is given in the instruction. Next one, register addressing mode. Instead of giving the data in the instruction, we give the data using a register. Next one, direct addressing mode. We are not giving the data, we are giving its address. So address is given in the instruction, applies only to internal RAM. Indirect addressing mode. Address will be given using a register. If it's internal RAM, you need an 8-bit register, you use R0 R1. If it's external RAM, you need a 16-bit register, you use DPTR. You can also use R0 R1 for external RAM. Nobody does that, but it's a facility. There's nothing wrong with it, it can still be used, but nobody really does it. And the last one, index addressing mode. Address will not be given by one register, it will be given by the sum of 2 registers. Another thing to understand is, move works on internal RAM. Move works on internal RAM. Move X works on external RAM. Move C works on ROM. Now which ROM does it work on? Internal ROM or external ROM? Yeah. When you do A plus DPTR, you get an address. If the address is 1000 and more, it will work on external ROM. because 1000 and more has to be external ROM. If the address is less than 1000, then depending upon the signal EA bar, please watch the videos before this, EA bar. If EA bar is 0, it will work on external ROM. If EA bar is 1, it will work on internal ROM. So for ROM, you have a common instruction, MOVC. It works for both internal ROM and external ROM. So you need an EA bar to decide which one will it work on. But for RAM, you don't have an EA bar because you have two separate instructions. You have MOV for internal RAM and MOVX for external RAM. So you don't need an EA bar. The instruction itself will clearly indicate whether you're working on internal RAM or external RAM. Please tell me, did you understand this? With this, we finish addressing modes. I hope you understood the whole topic.